So I'm super excited to now be on the other side. So instead of hosting, actually presenting. So thanks for having me. My name is Sophie Van Der Zee, and I'm going to talk about two different topics. One is the personalized deception detection, and the other one is Trump. So I didn't do this by myself. I had an awesome research team, very multidisciplinary. Ronald Poppe, computer science, Alice Hervelek, design student, and Aurélien Bayon, behavioral economist. So normally in deception research, what do? We basically test things on groups of people. So each person either tells one truth and one lie, or a truth and a lie, and then they leave again. And we compare differences between groups. But in practice, people have to judge the person sitting in front of them, the person they're interrogating, for example, or interviewing. So what you would then need to do sort of personalized deception detection is that you would need many statements by a single individual. But that's not the type of data that we normally get either in the lab or in the real world, because even though in the real world we have had fact checkers for years, for a long time, there was no single individual with enough fact-checked lies that we could create a personalized deception detection model. But then there was Trump. Thank you, Trump. In the 4 years that he was the president of the US, he made over 30,000 false or misleading claims, according to the Washington Post. So what did we do? Because he communicated a lot through Twitter, we decided to analyze his tweets. We collected, in study 1, we collected a data set worth of 3 months of tweets in 2018. In total, we had 469 tweets. And we then connected our tweet database to the fact-checked database from the Washington Post. So we collaborated with them. So we knew for each tweet whether it was factually correct or incorrect. We then did a linguistic analysis using the Logit software, and we compared the language use of the factually correct and the factually incorrect tweets. And what we found is that there were many linguistic differences between the factually correct and the factually incorrect tweets. So in red, you can see what he used more when telling incorrect things in his tweets, and in green when he was saying correct things. So the lies is incorrect in red, and the truths are basically green. The bigger a category, the more important. So you can see that his correct tweets were more emotional, more positive emotional, more hashtags, more religion, more exclamation points. And his lies were more third-person pronouns, more cognitive processes, more negations, and he used more words overall. So we ran a MANOVA, and we found that 35% of the word categories differed between the factually correct and the factually incorrect messages. And this basically supports our deception hypothesis that he was aware that there's a difference between them. So that he's not just wrong, but he's probably lying in some of the cases. We then created a Logit model to see whether or not we can also predict for a single individual tweet whether it's factually correct or incorrect. Such a model could, for example, help fact checkers do their job. So on the left-hand side, you can see which of the Logit variables ended up in this model. And with this model, in the same data set, we achieved a 73% accuracy in determining whether a tweet was factually correct or incorrect. But of course, when you create a model and test it on the same data, there might be overfitting. So what did we do next? We collected a second data set, did the exact same thing, again, 3 months worth of data. We had 484 tweets, connected it to the fact-check data set from the Washington Post, ran a Logit analysis. And this time we applied the model of study 1 to the data set of study 2. To test out of sample prediction, basically. Well, this is our ROC curve. In black, you can see the line of study 1, in gray, study 2, and we found a 74% accuracy this time. So we had stable out of sample prediction. Then the question remains, and now we have a personalized model for Trump, but does it perform better than the models that we already had in the literature? Because of course, we're not the first to do Logit-based deception detection. So on our third study, we gathered 24 models from 14 papers that we could find in the literature. We did the exact same thing as we did for study 2. So we trained the models from those papers on data set 1. We created a model with weights, And then we tested this model with these weights on dataset 2, and we compared the different models to each other and to our model. We also added a couple of benchmarks, including word count only and random guessing. And this is the results. Our paper did best, both with and without the Twitter variables that we included, hashtag and @ we scored 5% point better than the best paper from the literature. There were also a couple of papers that scored below guessing. So we had 74% out of sample accuracy, and the next one 69. This was my talk. Thank you for listening. We also created a website, a personal model of Trumpery, where you can actually check specific tweets, and you can click a button and it will tell you whether it's predicted to be a truth or a lie. Thank you.